Patterns. One of the most powerful aspects of math is the concept of describing patterns. In fact, many mathematicians will describe mathematics as a language of patterning. And certainly with algebra, we'll see how powerful it can be to pattern certain things. So let's take a look at a few patterns, and I'd like you in these next ones to see if you can figure out what the next number is in these lists of numbers. So 5, 10, 15, hopefully you can count by fives and get that one. How about 14, 11, 8, blank. And make a little bit of a harder one here. 2, 3, 5, 8, 13, blank. Well, hopefully you got the first two fairly quickly. This is a pattern of adding 5, adding 5, adding 5. For B, you're subtracting 3, subtracting 3, subtracting 3. The pattern for C is a little more difficult to come up with. So hopefully you can get 21. If you can't, please let's start off with a discussion in the first class about why that's 21. And remind me to tell you a little story about the CBC. Well, it's all good being able to come up with the next number, but what if we wanted to get, say, the 100th number in the list? That becomes a lot more difficult. Well, let's take a look at the first one, because 5, 10, 15, 20 is a fairly easy pattern, and see if we can come up with a way of generating the 100th number. So here's some things. This first number, I'll call it number 1, and then to the second number has a difference. It goes up 5. And that's the pattern that continues. So you also go up 5 to number 3, and you go up 5 more to number 4. And what we want to know is, what's that number 100 worth? So this is where algebra becomes really powerful, and a general equation is useful to help us out. And here's what that can look like. The value of any number. So the value of the first number is 5. The value of the second number is 10. The value of the third number is 15. That value depends on two things. It depends on the first number. In this case, that's 5. But in other patterns, that's not necessarily 5. And it also depends on how much you're going up or down by. So this is the difference right here. In our case, that's plus 5. So this is a 5. And then that gets multiplied times something. And it gets multiplied by n minus 1. And the reason that it's n minus 1 is that this is a multiplication, a difference of 5 for each number in the list after our number, or our first number. So really I want to add 5 99 more times. Not 100 more times, because I would be at term number 101. I want to add it 99 more times. So I start off with 5, that's my first number, 5, and then I add 5 more 99 more times. So add it once, add it twice, add it 3 times, until I get 99 more times to get to the 100th number. So let's take a look and see what that's worth. The value of term number 100 should be 5 plus 5 times 100 minus 1, and that's 5 plus 5 times 99. 5 times 99 is 495, so 5 plus 495, which will give me the 100th term as 500. We can also check and see if it worked for some of the early ones. Is the first term, I'll use a little subscore 1, and here I could use a subscore 100. Is that first score able, is this general equation useful for that too? Well, 5 plus 5 times 1 minus 1. 5 plus 5 times 0, 5, and then don't add 5 any times, so 5 plus 0, which is 5. Oh, it seemed to work. Will it work for the value of number 2? 5 plus 5 times 2 minus 1, which is start with 5, add 5 just once. You don't need to add it for the first term, so you just add it one more time, and 5 plus 5 is 10. So, yeah, 5 and 10, yeah, 5 and 10, so this 500 should work as well. Let's take a look at the second list that I gave you and see if we can figure out the 100th number from there. So it was 14, 11, 8, 5, and I need to know what the first number is, and then I need the difference, and in this case each time you go you're going down 3, so there's your difference, and then that multiplies by n minus 1, and I want to know the value of the 100th number, so I start with 14, I go down 3 times 100 minus 1, so 14 minus 3 times 99. Yes, you can use a calculator if you have to. 14 minus 297, the negatives win by 283. So the 100th number in this sequence should be negative 283. Now that pattern won't work for this last sequence that I gave you of 2, 3, 5, 8, 13, 21, etc. And the reason that it won't work is there isn't a common difference between each term. So I only add 1, and then I added 2, etc., etc., etc. It changes. This formula, this common difference type formula that I gave you, will only work if the numbers are in order and if they have a common difference, either going up by the same amount every single time or going down by the same amount every single time. Let's take a look at some patterns as described by tables. So in this section I'm going to give you a table, so it just looks like this. Some x values and some y values. So maybe x is 0, 1, 2, 3, and 4, and the corresponding y values can be 5, 9, 13, 17, and 21. And my question here is, how can I come up with an equation that will describe this pattern and continue the pattern forever? So, first thing that you should notice when you're looking at these patterns, this one's going up by 1. And this one is always going up by 4. So hopefully we can use something similar to, okay, term 1 is equal to this, and therefore the common difference. Hopefully we can use something sort of similar to that to solve this one. So, is there any relationship this way either? Well, it doesn't really look like there's, just add 5 in the first one, but then add 8 in the second one, and add 11 in the third one. This doesn't look like as much of a pattern. So here's a trick. If you have the x values all going up by 1, and the y values are going up by the same amount each time, you can rewrite your table. And I'm going to make it a little bit bigger. So I had x and y. Let me just copy that out quickly. And now I'm going to create a column called 4x. And the place that I got the 4 was from this adding 4 every single time. So I have x is equal to 0, 1, 2, 3, 4. 4 times x would be 0 times 4 times 4 times 4 and times 4. So now I have a column called 4x, and is there a pattern now from 4x to y? And there certainly looks like there's a pattern, because every single time here you just add 5. So I can come up with a general equation, and it looks like this. The y values are, so these y values, all of them, are equal to 4 times the x value. So if you take the x value and you multiply it by 4, take the x value, you multiply it by 4, you end up with that middle column, and then to get to the y value you have to add 5 more. Okay, so this pattern works for every single one on this table, and I'm going to assume that if this pattern continues, it's going to work for all the other ones off the table. For instance, for 5, we know that we would just add 4 and you would get 25, so I should be able to do 4 times 5 plus 5 more and get my magic number 25. So it looks like it's going to continue to work. Let's take a look at another one where the pattern is a little bit different.